Far beyond the planets, far beyond Pluto, and even beyond the Kuiper Belt, there exists a vast and invisible region surrounding our solar system. A place so distant that no spacecraft has ever reached it. A place known as the Oort Cloud. It is here that scientists believe trillions of icy objects remain suspended, relics from the chaotic birth of the sun. Ancient fragments, barely held together by gravity, drifting in silence for billions of years, waiting for the smallest disturbance to begin an unimaginable journey inward. According to modern astronomy, this distant cloud is the source of most long-period comets, objects that appear suddenly in our skies with no warning, moving fast and arriving from directions that defy intuition. And this is also where 3I Atlas most likely came from. When astronomers revisited the early data, the strange trajectory that once hinted at an interstellar origin began to look different. The orbit was extreme, yes, but not impossible. Vast, elongated, and sharply inclined. Exactly the kind of path expected from an object that had spent eons in the outermost reaches of the solar system. The Oort Cloud hypothesis is not built on speculation or imagination. It is supported by mathematical models, gravitational simulations, and decades of accumulated evidence. Passing stars, galactic tides, and even subtle shifts in the sun's motion through the Milky Way can destabilize these distant objects, slowly nudging them toward the inner solar system. Most never make the full journey. They drift for millions of years, altered by forces we barely perceive, until their paths change again and they vanish back into darkness. But a few are sent inward, and when they arrive, they do so dramatically. To observers on Earth, these objects seem to appear out of nowhere. They move quickly, their trajectories look unnatural, their origins are unclear, and in the earliest moments after detection, they can easily be mistaken for something else entirely. This is where confusion begins. An object falling from the Oort cloud can look nearly indistinguishable from an interstellar visitor, especially when observational data is limited. A difference of fractions in velocity or angle can completely change the interpretation. Bound or unbound, local or alien. This was exactly the situation with 3I Atlas. Early orbital solutions placed it dangerously close to the threshold between solar and interstellar. The margin of error was small, but the implications were enormous. A few incorrect assumptions, a short observation window, and suddenly the object seemed to challenge everything we thought we knew. As more observations were collected, the uncertainty faded. The orbit slowly closed. The data converged, and 3I Atlas settled firmly within the gravitational influence of the sun. Yet the story did not lose its importance, because the Oort cloud itself remains one of the greatest unanswered questions in astronomy. No telescope has ever directly observed it. Its existence is inferred, not confirmed by images. Everything we know about it comes from indirect evidence. The behavior of long-period comets, statistical distributions, and the laws of gravity applied on cosmic scales. This uncertainty means that every new object from the outer solar system becomes a test of our models, a test of our assumptions, and sometimes a test of our willingness to admit how little we truly know. In this sense, every object like 3I Atlas is more than a comet or asteroid. It is a messenger. Each one carries information from a region we cannot see, from a time before planets fully formed, from the earliest moments of the solar system's history, preserved in deep freeze far from the sun's warmth. These objects are older than Earth, older than oceans, older than life itself. They represent a cosmic memory, largely untouched, drifting at the edge of gravitational influence. And yet they remain among the least understood members of our cosmic neighborhood. The case of 3I Atlas reminds scientists of a crucial truth. Extreme orbits do not automatically imply extreme origins. Sometimes, the only parts of our own system can appear just as foreign as interstellar space. In fact, the Oort cloud may blur the very boundary we rely on to define what is ours and what is elsewhere. If objects born around our sun can travel so far, remain so altered, and return in such unfamiliar ways, then the solar system is far less isolated than we once believed. In the end, the Oort cloud hypothesis does not eliminate the mystery, it deepens it. Because if our own system can produce objects that convincingly mimic interstellar visitors, then certainty becomes rare and humility becomes essential. And as our instruments continue to improve, one reality grows increasingly clear. The next object that challenges everything we think we know may not come from another star. It may come from the darkest, oldest, and distantest edge of our own home.